little bit of background, just to give you an idea, maybe some of the attitude that I personally have as I think about these things. I've seen a lot of projects over the years sort of have very ambitious goals for themselves with regard to performance or anything else, but then sort of crash and burn and fall short of those goals along the way. And that's sort of something that troubles me a bit as an architect and a designer. Or, you know, worse, they just don't even try. You see that a lot too. You know, it's especially here locally in the States. I feel like we don't see enough work with really ambitious goals. So to me, it sort of begs the question of how do we get more people thinking that they can push the limits when maybe they think they can. And that extends beyond the architecture team. I think that the reasons why those things kind of happen, either things fall short or people just don't try, are sort of two categories at the end of the day. Either there's sort of a disjointed approach where it's like, okay, you planner do your thing, you architect do your thing, you engineer do this thing, and there's not enough sort of back and forth or willingness to understand each other or blend things. And I think lack of consensus is another big one, whether it's within the AE team or within the AEC team with the contractors or even the clients. So you sort of get this idea of you're going to take things super far in some direction or another that you decide is important for the project. And then somebody comes in at the very end and says, oh, no, I don't like the way that doesn't look right. Like, let's add this curve. And you're like, well, now it sort of broke the whole reasoning. Or contractors comes in and says, oh, I don't think I can build that. That's going to be too expensive. When, you know, it's not necessarily true. So we try to use tools to sort of fix that process. And adjust those two categories. So historically, you know, we've each kind of had our own tool that we bring to the table as architect, as engineer, as owner, contractor, whoever. But we really need a lot more than just one tool, and a lot more actually. Tools that allow us to sort of challenge each other more and get into each other's heads a little more and each other's scope of work a little more, I think. And tools that force us to learn a little more too, because this idea that so-and-so is the expert, so I can't challenge them is really a big hurdle to get through. So we look for tools that can help address those things too. And you know, I think you guys are all here because you're interested in computation and parametrics, or used it at some point or another. Really the most important part of this is getting feedback quicker, whether in some form or another. This is kind of a circle around, you know, energy modeling and building performance. You know, traditionally you wouldn't get that feedback until too late to really do something, and that sort of sucks. But it goes for other things too. You know, whether it's in conceptual design as you're starting to think about the massing of a new building, or fabrication of pieces and parts as the building is being completed. So, a couple of case studies. This is a project on the north side of Chicago. So this was one of the first things we did as we looked to find ways to sculpt the building to shape the experience directly, but also do it in a way that was supported by metrics. So this is pretty straightforward, using Ladybug to analyze how much incident solar radiation is hitting the building. And we did this at a very specific time because we were interested not only in achieving better annual results as far as energy consumption goes, but offsetting initial costs. So we looked at the time of year when mechanical engineers will look at a system and weather data to size their initial equipment. So by decreasing the amount of solar radiation and the heat gain on that day, it's like August 21st at between like 3 and 5-ish, 2 to 5. We were having beneficial effects on both ends. So that kind of set up right away an ability for us to say that we initial cost as well as annual energy consumption. So because it's such a quick time period, we're able to do fresh solar radiation calcs essentially on the fly, and you're seeing how fast it goes here. Have you guys used Ladybug? How many of you use Ladybug here? So done stuff like this? Yeah. Talking. Cool.
Did you optimize the building based on this analysis?
We did. So the sort of shape that you saw the building in that very first slide is essentially a result of that. So we have this sort of inside curve here, and then there's sort of a bulge that self-shades a little bit. This is a west-facing facade, and you can see the sunshades here in the south facade as well. And then this bit right here is angled downwards, which helped a lot on the south facade.
So who were the engineers?
This is K2WW. So as we're doing that stuff, we're kind of doing it for ourselves, and we're sharing it with our engineers, and we're all getting excited, ourselves in the back. But we were also, I'm just going to leave it like this so I can toggle back and forth for the videos. We were also making sure that we told the story to the client so that they would have something to latch onto. As we talk more and more about this, and this is where the consensus building comes in, both the client is getting very, very excited, which in turn forced the contractor, whether they like it or not, to get excited. Oftentimes they're a big speed bump at phone. I'm sure you have too. So we were doing these very simple diagrams like this. We were also doing, at the time I had done this in Ecotech, not with Ladybug, to get a little bit better sense of how the sunshades were acting on a single floor. Around this time, we were also getting design assist partners involved in the project, and one of them was for the curtain wall system. So as we were doing these things, they were also running these analyses on different systems. So this is a double glaze versus a triple glaze curtain wall that we were looking at. They did this whole table that we ended up directly inputting with the engineers on different systems, both double glazed and triple glazed, so that we could try and we could understand the cost, the structural implications, and mechanical implications of all those things together. A really cool story that I like about that as well is that we ended up with a double glazed system, but we were able to sole source it to Schuco, who outperforms every other double glazed system by far, if you're not familiar with them. In terms of U values, traditional system might be 0.35, 0.4 U value. A traditional triple glaze might be 0.2-ish. We ended up with 0.27, which is even with double glazing, which is really beneficial. And what we were able to do, again, talking about kind of all the buckets mixing, we worked with the mechanical team and the contractor to say, look, we've got this really great performing curtain wall. We think we don't need perimeter heat, even though it's floor-to-ceiling glass. And that allowed us to take a bucket of money and say, all right, we're gonna not worry about perimeter heat. You get to put that towards your curtain wall, and it's another win-win where you're using less annual energy, and you're also offsetting initial costs. So that was a nice outcome. Let's see if this media plays. No, awesome. So not too long later, as we were in construction, we got into a little more detail with the sunshades that I pointed out earlier on the south facade. And it was kind of, I had a lot of back and forth with the contractor on this one, as well as the curtain wall design assist partner. There was a lot of concern that they couldn't actually build these because it curved in plan, and our sunshade had an arc to it. It was also angled down slightly because we found that was better for shading purposes. And they were like, wait, you're curving in section and in elevation and in plan. I can't do this unless I totally break bank. And so what I used this tool to do was demonstrate to them how they could actually unroll each one into single sheets. And I have the numbering system corresponding back to that there. But as they gave me more information about how they were able to fabricate these pieces, I was able to create parameters to adjust things and make sure we were still happy with the outcome. And that sort of led to us being able to actually pull off these sunshades, which was a great way to use the parametric tools that you don't oftentimes get to hear.
Did you get any variation from those shades, or were they all similar, or did you did some sort of a cluster and say like, oh, I got like 10 of them that are similar, but I got
so we wanted them to sort of taper off to nothing as they wrapped around the curve of the west facade. But we didn't want them to all end uniformly. They sort of staggered in the way that they ended, which led to a chunk of them being the same in the south facade. The tapered ones being different along the ends, but even still, there was some, like sometimes over here was still the same as up here somewhere. So I was able to quantify the number of unique profiles for them with this as well.
How early in the stage of the design did you do this?
So,
or was this like?
This was during construction administration. So we were working through, because it was a design assist partner, they actually started their shop drawings as we were drawing our construction documents. Mm-hmm. We let them go to town on it, and then once we were done with our construction documents, we started reviewing the details of these sunshades and more specific. All right, that's it for Masonic. I was going to move on to the next one, unless anyone wants me to elaborate or ask any questions.
Can you explain a little more of the glazing and the, because you had this various types of glazing, right? Did you do a matrix of those with the glazing and the facade? And how did you show that to the clients and the rest of the team? Because you have like 10 and then you have 10 different types, so you have a complex matrix, right?
The glass type is actually the same.
Okay.
We used one glass. The matrix that was created was like every single variable you could imagine. So it was double glaze with 2 different manufacturers. It was triple glaze with 2 different manufacturers. It was, are we using 1 low-E coating or 2 low-E coatings? Are we using aluminum spacers or stainless steel spacers? And we evaluated the U value and the condensation resistance for each of those, and it ended up being a matrix of, I don't know, maybe a dozen rows and 6 or 7 columns. But they had actually run very specific models with our curtain wall volume layout, so that each of those was as precise as it could possibly be. And they were using Therm and I don't remember the other tool they were using. But they were using a couple different tools to evaluate those systems. Hospitals, if you're not aware, are particularly challenging with condensation resistance because they're humidified, which means they're more prone than an office building to condensing over cold days. But this has now been through 2 harsh winters, and thermal comfort's great, condensation resistance is working out really great. So it's a nice success story.
What do you think is the best way to document, like during CDs, a design like this for, I guess, to make CA go smoother, just, just for,
So,
yeah.
I think it probably depends on the delivery process. Because this one had contractors and design assist partners on early, it was different. If you were doing a design bid build, I would probably actually do all this and have a sheet or a set of sheets that number coordinated each one, because otherwise the contractor's they're never gonna do that themselves, even in a competitive environment. It'd be pretty rare. So, in that case, I'd want to do it as early as possible. In this case, I was actually using this tool to make my life easier, so that as I was reviewing the shop drawings on the shades themselves, I could feel comfortable with what they were showing me, because they were using traditional 2-dimensional drawings. But I shared this with them, obviously, to prove them when they had issues and things like that. So this is an office headquarters building under construction in Oak Brook right now. You're kind of seeing an entry here, and there's a front yard, backyard thing going on. This is the back side. We have an architect on site daily, and he sent me this photo not too long ago, and I just thought, oh, that's pretty cool. So good to see it being built. In terms of design process for this one, I think we tried to take what we learned in Sonic and really apply it and look for more things, more tools that we could use to get each other talking more and get the building working a little better. So back to my complaints about people not always being in alignment and sabotaging each other, either intentionally or not realizing it. We started off the whole project by saying, all right, what's the most important thing to you? And what was great is on every single level they had at least one thing or two things in common that we could respond to. And the one that stood out the most was they were in these the company that's occupying the building. They're in 4 separate buildings now that were all built anywhere from the 60s to the late 70s. And there are these super deep floors with no windows, and they all wanted more light. So we're like, okay, these guys, to be totally honest, if we wouldn't have pushed it, would not have cared at all about performance or sustainability. But I know they care about daylight, so we're going to use that as our excuse to push this. Let's see if this is too long. So one of the first things we've done is we looked at massing. Was again trying to optimize for solar radiation. This time though, we had enough wiggle room on the site to where the building could do a few different things, and we kind of thought we had this hunch we wanted to curve it, so we built in these parameters to test it. And then we tested it in the summertime at that peak heat value, or the peak cooling load value that I mentioned earlier, but we also started looking at it in the wintertime and tried to balance the two. I was really hopeful that as we got into Galapagos, that I could write a formula that would magically make it the best possibly could be. Couldn't quite get there, so I ended up sort of real time displaying the information. There was an iteration after the one you're seeing in the recording here where it didn't say just the summertime total radiation, but it also said that winter time. So I could try and balance when we wanted to maximize it in the winter, minimize it in the summer. So that was kind of a useful exercise. If you guys haven't used Galapagos, it's a pretty powerful tool. It's like guess and check on steroids. And if you're looking to use it, I would highly suggest checking out David Rutten's blog posts. He's got like 2 or 3 of them that he wrote about defining fitness formulas and at least evolutionary modeling. They're really good. It doesn't take too long to read it out. It's not really long copy. So while we were doing that, we also had our mechanical team again running just iterations and iterations and iterations. They were happened to use eQuest. I would have rather they were using Energy Plus, but you can't always get what you want. But regardless, we were having them look at different curtain wall types. We were having them look at different sunshade configurations, all different window to wall ratios, insulated values for the roof as well as the walls, different solar heat gain coefficients, all that stuff. And we were having them tell us what the pros and cons of each of these were as they stacked up the iterations. This is actually only a small section of what they tested. The full one is probably like 5 or 6 or 7 of these sheets. What was great about it though is that we were able to ask them, okay, now don't just tell me my annual electrical savings from any of these moves. Also tell me what your peak heating, your peak cooling, and your vent requirements end up being as a result of all these things. So we started to situate ourselves in a really, I think it was a really powerful way of saying, okay, we know that we don't want the sunshades to be more than 2 feet deep because then they actually block too much sun and you don't get the stuff you want in the winter. And by the way, as a result, this is how many tons of cooling you need in a building versus, so you'd be saved 5 tons or something like that. So that was a great metric. And this time the engineers were ESD. While we were also working on those sort of outside-in factors, we were pushing on the inside out. So we had started having workshops with the tenants about how they wanted to work, and knowing that where they put closed rooms has a pretty big impact, not only on the energy use, but also on the daylight, how much light you can harvest. So we started talking about, all right, if you've got these closed rooms and light's important to you, and this is where you really need them to be, then I'm gonna make the building do this in response. So like, you know, if you're really in love with putting a bunch of offices on the outside, that sucks. I'm gonna make you put an atrium in, and your building's gonna get kind of different. So there was sort of simultaneous reviewing of all that stuff. And while we were doing little cute diagrams like these, we were also showing them metrics of how a different shell would perform in terms of, we use continuous daylight autonomy. I felt like that was the best factor to use, which, if you're not familiar, basically says how often can you rely purely on natural light. And if you can't rely on it 100% of the time, using partial bright, whereas other metrics don't. So we were showing them these things, and then we were also saying, okay, look, this is what that does to the shell of the building, and that's what this does to your light loads. And I guess this one isn't later. I think it's this one. So here we're getting into using Honeybee, and we'd set up this sort of super grasshopper definition that was able to look at almost any of the Honeybee daylight related components or items that you'd want to evaluate. So we were looking at continuous daylight autonomy, like I just mentioned. We're also looking at daylight factors, just because that was an important metric to some agencies that we were working with. We were looking at shadow studies, because at one point we were thinking this thing should be 2 bars, and we wanted to get them spaced apart just right, so that they were doing only the right amount of self-shading. We were, you can see here, we made it fatter for them so they could see what would happen. This one also is set up to do the glare analyses, like the true hemispherical glare analyses, so we could start to think about, if you, back to that planning thing, if you put your offices in these sort of locations versus another, then it's creating a separate sort of glare challenge for us to look at. We use that tool to analyze whether or not a light shelf was actually performing for us or not, and also build a case for, at the end of the day, we used automated shades on the interior that were tied to building automation system, as well as the light sensors on the exterior. So we were able to kind of balance a lot of these things at once. Here, I think at the end, you're seeing the glare analysis, the glare probability index. This was so early this was like right after we built the definition that there's not much to it. So the glare rendering wasn't really telling us a whole lot just yet, but it did later, which was pretty cool. Have you guys used Honeybee for these things?
Did it run pretty fast when you were doing this?
This doesn't run as fast.
We used glare before, and it takes special.
Yeah, it depends on how much detail you have in your model. What I really like about these early models and these tools is that you can use the same very simple model to render an idea as you can to simulate and test an idea. And you'll see a slide in a minute. I don't have a recording of it, but also the same very simple geometry lends itself pretty well to being interoperable between other systems like Revit. So you can do a lot with a very little, and I bring that up in response to your question because less means less time. So if you've modeled your mullions as perfect little rectangular cubes, it's going to take a lot more time than if you just model it as a simple plane or like a T-shape if you want to try and model it.
Would you you be doing just a simple model, of, let's say an area, and then do it more defined, and then see like, all right, yeah, I might teach things here. Let's try.
Absolutely. Yeah. And so like when we were doing these a little bit later, we picked, like the west, and we picked the south, and we picked over here on the east, and ran the simulations that like at just those locations. Glare is one of those really hard ones because everyone wants to have a plan-based simulation to kind of understand what's going on. And every metric we have for looking at glare and plan is basically a guess, albeit by a group of engineers and lighting experts that make a guess. It's just not quite there yet because at the end of the day, it depends on what you see, and we don't have that.
Are you getting clients that are asking you to look at these things, or is just Smith Group or the leadership there that invested to divert actual like project dollars to letting people spend time on this?
Not necessarily either, actually. So this was something that was done just as a part of our design process. So because we knew we had to build a simple model for X or Y or Z, we just did this. And we showed it to the client so that they would know. And it was funny because there were some engineers within the company that we were working with that were like really into it. But there was a lot of people, especially the ownership, that was like, I don't really get it. And we'd talk to them about it. And they'd be like, okay, I'm glad you did it, and move on. But what was actually really great is, I'm not sure if I have a slide to it, I think I do. As a result of having just sort of done it, there came a point where the contractor was like, I'm really sick of this architect trying to do this long skinny building. I hate the perimeter to volume ratio. It's gonna cost too much. And without getting too much further into it, we just very quickly said, well, this is what it looks like at different widths, and the one all the way on the right is what the contractor was really pushing for. So we said, well, we can consider that, but you need to know, right, first and foremost, this is the effect. And the client responded immediately. It was like, no. So as a result of having they didn't ask for it, but we just did it, it actually became a really important driver for the project. And as Smith Group leadership has seen us use this tool now over the past 4 years, they're more and more interested.
Because I find it fairly easy to convince somebody on the design side or the design leadership to buy into this, but I get into issues with a project manager, the managing principal, who's not sitting there, not watching what's happening, and all he's seeing is like what you're doing per day and what he can charge and bill towards what you're accomplishing on a set in Grevit. Like right. This doesn't compute, and so that's where I end up running into roadblocks a lot with this process.
For sure.
In the ideal world, I think we've been at places where it's just kind of, you don't talk about it, it's just part of the design process, but it's not like that everywhere.
No. So when we were introducing these tools at Smith Group, we, at the beginning, there's always some people who are interested in it, and you just sort of made it a part of everything you did. And some people, project managers in particular, could be a tough crowd. But we just took the approach of asking for forgiveness rather than for permission. And when they started to see it being used enough, and that the projects weren't being hurt from a financial standpoint internally as a result, then more and more people started to become interested. And I think that the industry in general is getting a lot more interested in these tools as clients are gaining a little bit of knowledge about them, even if all of that knowledge is, oh, I heard that's a thing and that looks cool when you do it. I don't know what it is, but it looks cool. And that helps win work, which helps wins over people who might be otherwise a bit cynical. it's not an easy road,
No.
but I definitely take the approach of, of asking for forgiveness, not for permission. And the reality of it is, like, these things don't take that much time. I mean, you might have to invest a little bit on your own to get the definition going, but you do that a few times and all of a sudden you've got a library to tap into. And running these things is not substantial. Which brings me to my next point, which was, unfortunately I don't have a video to show you, but we tested on this particular project several different interoperability tools. I really like Hummingbird. Lyrebird is also really useful, and where those two have a gap, Grevit is pretty great too. I don't know if you guys have used those at all. But what this sort of allowed us to do was take our concept model, which we were using Rhino, and we're using it to render, we were using it to simulate, and then with a few extra components added onto the end of that model, we were able to say, okay, let's populate column grids, levels, mullions, curtain walls, the whole bit. So for our schematic design, this was huge because it allowed us to take a couple of very simple families and a little bit of extra investment in the already in place grasshopper definitions and go from basically nothing to a full schematic Revit model pretty quickly, less than an hour. I will say, getting into the weeds for a second, on this project, I personally have never liked curtain walls in Revit. So to set this one up and to get this interoperability working really, really great, we actually modeled the curtain wall as our basic wall in Revit terms and made it a 1-inch thick piece of glass. And each of the mullions was a family. So we used Hummingbird to get all the grid lines, to get the floors, to get the walls. And then I used Lyrebird to place each of the mullions as a family, which worked great and also overcame some of those like nuanced, annoying stuff that curtain walls do in Revit, like having to place each grid manually and the top and bottom are never really where you want them because they suddenly aren't center lines anymore. They're ends and mullions and stuff like that. So and those tools are still available. I know Hummingbird had a counterpart called White Feet for a long time, and that one sort of, will he keep writing it or won't he? Which is why I bring up Grevit, because they fill in a lot of gaps there too. But I did find Hummingbird personally to be the most robust and sort of foolproof.
Was Dynamo out? What is that? Was Dynamo Revit out?
Yeah, Dynamo was out, and I've delved very shallowly into Dynamo and need to get into it more. But I didn't know at the time, and this was a great way to make the grasshopper model talk with Revit. I think there are tools now, I've heard of them, I haven't seen yet, that allow you to have grasshopper communicate to Dynamo, communicate to Revit. Haven't tried that yet. I don't know if you guys have it all.
And they're good.
They're good? Nice. Last thing that was kind of cool about this one is getting back into Honeybee, the exact same tools we used in concept design to sort of inform and build the mass and get the client and everyone on board were the tools we used to get our verification for lead on the daylight credits. So same tools, just a little bit of tweaking to get some specific information that lead asked for, and we're able to churn out the spreadsheets and the plans, and if you could zoom way, way, way in, you'd see the little number values of the light levels on the floor plan there. But it was, I thought there was a really nice continuity to be able to use the same tool for both conceptual and verification. We'll get into the project really. So those are just two case studies. We've been dabbling with more. I know master planning is something that Smith Group does a fair amount of, and we're really, really interested in and been tinkering with ways that we can use Grasshopper to inform that process. When you're working locally, we do projects in China. If you've ever done a master plan in China, it's like everything from scratch or Saudi. That's kind of a different plan than you oftentimes see in the States, which actually tends to be more complex. It's sort of interesting. But it typically involves some existing set of buildings that you need to analyze and consider where to move things around, condense, make room, put in any other piece, stuff like that. We found so far the TT toolbox to be incredibly useful because it allows us to link database information to geometry. We've found the human interface extremely helpful because if you can do things like, rather than have to have your Grasshopper and Rhino model on display for a client, you can have the human interface out in front and do things like click on a building and now it explodes into its separate floors, or highlights the different areas of the building that have older or newer mechanical systems and things like that. So it becomes a bit of a data visualization as well as a design tool. There's other stuff too, and these are just a couple of ways that we're using it. And you guys we're not by no means the only ones using it. So I'm actually really curious how all of you have used it, these types of tools, if anyone's willing to share. No? We're the only ones using it?
I mean,
What do you use human to?
Yeah.
Human UI to for some use that TT toolbox.
Yeah.
But I don't know, for master planning and some of that, we were teaching some of the elk tools before.
Oh yeah.
So elk is pretty great. We have another one which is added. Added is it's one that somebody in the office has built as well. It's GIS data, bringing it into Lyrebird for documentation. So you can extract anything from building height, corner, stuff like that. So
That's pretty cool.
Yeah.
You guys are coming up with all that good stuff right now.
The guy from
Stop.
Grevit works for as well. So, yeah, I mean, we're seeing more people build tools for Jewish thing. But this is great watching the way somebody uses Ladybug and Honeybee and built environment. But yeah, stuff helps with us for a while.
Cool.
I think that's impressive. I think he was doing something as much as this, but like this is great.
No. Alright. Cool. I had to put a couple slides at the end here. So what, I guess, is what I hear a lot. I guess the way I see it is the design process requires a lot of tools, and it requires us to establish a vision, but also to kind of dabble in each other's work. And I'm a big believer that if you're designing something, you don't necessarily need to be the expert, but you can't be relying completely on somebody else to assembly line approach to architecture, as I think of it. Like, I do my little bit, then I kick it down.